This is the video for section 1.2. We're going to talk about angle relationships and similar triangles. First, we're going to go over a little bit of review from geometry. The first thing we're going to talk about is vertical angles. Vertical angles are just the ones formed by intersecting lines. In this figure, we've got two pairs of vertical angles. The first pair is QMN and RMP. So this angle and this angle. The second pair is QMR and NMP. So it's this angle and this angle. The property that vertical angles have is that they have equal measures. So we could say that they have equal measures, or we could say that they're congruent. The next thing we're going to talk about is a specific situation where we have two parallel lines and then a line that's intersecting both of them. In this case, the line that intersects the two parallel lines is called a transversal. And this gives us lots of properties for the angles that are included in this picture. So we're going to go over the terminology and then what the properties are for those types of angles. The first ones we'll talk about are alternate interior angles. Interior means that they're within the parallel lines, so they're between the parallel lines. And alternate means that they're on opposite sides of the transversal. So in our picture, angles 4 and 5 would be alternate interior angles. And what happens with these is that their angle measures are equal. So again, we could say that the two angles are congruent. There would also be another pair of alternate interior angles here, and that would be this angle and this angle, which was angle 3 and angle 6. So this angle and this angle would also qualify as alternate interior, and those two would also have equal measures. So we could say that angle 4 is equal to angle 5, and also that angle 3 is equal to angle 6. The next one we're going to look at is alternate exterior angles. Exterior just means that they're on the outsides of the parallel lines. So this angle 1 is on the outside of the parallel line M, and this one is on the outside of the parallel line N. Alternate again means that they're on opposite sides of the transversal. So we've got angle 1 and angle 8 that would qualify as alternate exterior angles. And again, the property that we're looking at here is that their angle measures are equal. So we could say that angle 1 is equal to angle 8. The other alternate exterior angles would be this angle and this angle. In our picture, that was angle 2 and angle 7. So we could also say that angle 2 is equal to angle 7. The next pairs of angles we're going to look at are interior angles that are on the same side of the transversal. So in this picture, we've got two interior angles, meaning that they're between the parallel lines, and they're on the same side of our line Q, which is our transversal. So these two, instead of being equal, their angle measures add up to 180 degrees. So that means in this picture we could take angle 4 plus angle 6, add them, and we would get 180 degrees. Now the other two that would be interior angles on the same side of the transversal would be this one and this one. So that would be angle 3 and angle 5. And we could say the same thing there, that those two would add up to 180 degrees. And the last relationship we can look at is corresponding angles. And this just means an angle that's in the same position relative to one of the parallel lines and the transversal. Here's an example. Angle 2 and angle 6 are corresponding angles because they're in the same positions relative to those lines. In this case also, the angle measures are equal. So we could say that angle 2 is equal to angle 6. And we could look at all the other corresponding angles. For example, this angle and this angle would be corresponding angles. So we would also know that their measures would be equal. Let's look at an example where we're going to find the measures of some of the angles in the pictures. So we have our two parallel lines and we have our transversal. And we've got two angles for which we've got an expression for the measure of the angle. So first we need to figure out what these two angles would qualify as. Notice that they're both on the outsides of the parallel lines and they're on opposite sides of the transversal. So that makes them alternate exterior angles. And what we said about alternate exterior angles is that they have equal measure. So we could say here that angle 1 is equal to angle 4, and then we could take the expressions for their measures and just set them equal to each other. So we'd have 3x plus 2 equals 5x minus 40. We can solve this equation for x. This will allow us to get the actual measure for each of those angles. So we can subtract 5x from each side. And then we can subtract 2 from each side. And then we can divide both sides by -2. This will give us x equals 21 degrees. Now that's just for x. If we want to find the actual measures of these angles, we need to substitute the 21 degrees back in here for x. So for 3x plus 2, we would have 3 times 21 plus 2, which would give us 65 degrees. So we know that this angle is 65 degrees. That means that this angle is also 65 degrees. If we wanted to check our work, we could substitute the 21 in here for x and work that out just to make sure that it also comes out to 65 degrees. So we know the measures of those two angles. Now we can get the measures of lots of other angles in this picture just by knowing those two. Angle 1 and angle 3 are vertical angles. So that tells us right away that this angle is also 65 degrees. Same thing with angle 4 and this angle over here. Those are vertical angles. So we know that those are 65 degrees. If we look at these two angles, those would be alternate interior angles. And we already see that their two measures are equal. Now if we look at some interior angles on the same side of the transversal, we could look at this angle and this angle, or we could look at this angle and this angle. Either way, those two are going to add up to 180. So that would mean to find the measure of that other angle, we would take 180 minus 65, which would give us 115. So this angle is 115, this angle is 115. And to get the measure for angle 2, we could have done lots of different things. One thing that we could do is just look at angle 1 and angle 2. Those two together form a straight angle, which means that they have to add up to 180 degrees. Or now that we have this angle over here, this one and angle 2 are vertical angles, so we know that their measures have to be the same. Any way we look at it, the measure of that angle is going to turn out to be 115 degrees. And then the only one in the picture that we haven't done yet is this one over here. Again, we could just look at the fact that this is a vertical angle with this one. It's also a corresponding angle to this one. With this one, it's a supplementary angle since the two together would make a straight angle. Now we have the measures for every angle in the picture. Now in this class, we're going to talk a lot about triangles. So there's another property of angles in a triangle, and that is that the sum of their measures is 180 degrees. If you add up the three angles in a triangle, they have to add up to 180. So here we have the measure of two of the angles of a triangle. We know they're 33 and 26, and we want to find the measure of the third angle. What I'm going to have you do a lot in this class is draw pictures. Even if you don't necessarily need the picture, for this one we could just go ahead and add these up and subtract it from 180, but it's going to help a lot to have a picture. So I'm going to go ahead and draw this triangle. I'm going to try and make it somewhat accurate as to those two angles. So we know this one is 33 degrees, this one is 26 degrees. We're trying to find the measure of this other angle over here, so I'm going to call this angle A. And what we know from our property is that angle A plus 33 degrees plus 26 degrees has to equal 180 degrees. So I'm just going to solve this equation for A. Those two add up to 59 degrees. So then I'm going to subtract 59 from 180. And that gives me 121 degrees. So this angle here is 121 degrees.